This is LeetCode problem 1, toSum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. In example 1, we get an array of nums 2, 7, 11, 15, and target is 9. Because 2 plus 7 equal to 9, then we should return the index for 2, which is 0, and the index for 7, which is 1. Let's look at an example here. We have an array of 7, 8, 9, and the target is 17. We are asked to find a pair x, y such that x plus y equal to target. Let's use hash map to solve this problem. For the first pass, we can store each number and the index in the hash map. Let's starting from index 0, then that will be number is 7 and index is 0. And then for the next number, which is 8, index is 1. Next number is 9 and index is 2. And for the second pass, let's say x starting from index 1, which will be number 7, then y will be equal to target minus x, which is 17 minus 7, 10. Do we have 10 in the hash map? No, we don't. So we don't return any number. And then let's keep moving x into the next index. Now the number is 8. We need to find y equals to 17 minus 8, which will be 9. Do we have 9 in the hash map? Yes, we do. And for 8, the index is 1. For 9, index is 2. And then we will return 1 and 2. This algorithm requires 2 passes. Is it possible to do this in only 1 pass? Let's try it. We initiate an empty hash map and then start x at index 0. Its complement y should equal to 10. Do we have 10 in our hash map? No, we don't, because now it's empty. So let's add number 7 and its index into the hash map. Now, let's look at index 1. Its complement, 9, does not exist in the hash map. So we add number 8 and its index 1 in the hash map as well. At index 2, we notice 9's complement, which is 8, already exists in the hash map. This means we found a pair that sums to the target. Now, we can return the indexes of the two values. We can find the index for 9, which is 2 in here, and find the index for 8 in the hash map, which is here. Then we return 1, 2. This is the coding part. We initiate an empty hash map. And then for I num in enumerate nums, complement equal to target minus num. If num's complement is not in the hash map, then we add that num and its index into the hash map. If we found the complement in the hash map, then we can just return the index for the complement and for that num. If we couldn't find any valid pair, we return empty. For this solution, time complexity is O of n. Space complexity is O of n as well.